Okay, fantastic. We're alive. Hello, everyone. My name is Max, and I'm one of the co-founders of Arcane Finance, a privacy-centric DEX on Aleo.
My name is Max.
Okay, I'm hearing myself. Give me a second, please. Yes, fix that. Yeah, so today is our second lecture about building on Aleo. This series of lectures is created by Aleo community. It's not organized by Aleo itself, and well, it's tailored for beginners. Yeah, so let's dive in. Yeah, a quick recap of the first lecture. So Aleo is built around privacy. So what makes Aleo different from other chains is mostly privacy. All the data is like encrypted. Well, not all the data, but almost all the data is encrypted, and well, it allows to achieve first privacy, and the second thing that is achieved is scalability, as the main part of the computations can be done off-chain, and zero knowledge proof can be generated, and well, it allows to scale better. So contrary to the normal regular blockchains, where usually computations are done on each node of the network. Here there is no redundant repetition, so validators can just check zk proofs generated by the program, and yeah, this is way faster and allows Aleo to be more scalable than most other chains. Yeah, so today's lecture is a little more technical, and we'll look into Aleo core concepts and like how all these parts work together. So let's start from the bird view on like what core concepts are. So there is an account and a record. Well, again, as we talked in previous lecture, there are both kind of Aleo mixes two concepts of account model, like Ethereum-like, and record model, UTXO, Bitcoin-like. So yeah, there are accounts and they can own records in Aleo, and well, there are programs, as Aleo is a programmable blockchain, and yeah, so there are programs that are also deployed on chain, and well, there are transitions described in these programs, and these transitions can create and consume records, thus like changing the global state of Aleo, and these transitions are combined into transactions, and transactions are combined into blocks, and these blocks are built in a blockchain essentially. So now let's look into each of the concepts a little deeper. So what is an account? Well, account is described by three keys. So like yeah, three values, so to speak. And here we can see that this is already slightly different from what we are used to in, say, Ethereum. So there are three keys. Okay, so the first key is the private key, and well, essentially it is a key that is generated cryptographically from a random seed. So essentially, like, this random seed is like the source of randomness for private key, and well, it's base 58 string, so consisting of 59 characters, and it always has a prefix a private key, which is like very convenient. I think this is a really brilliant thing, because well, it easily allows you as a user to distinguish keys of different type, and you will never accidentally send someone your private key thinking that it is your public key or a view key. And well, so the private key, the goal of the private key and the function of the private key is to sign transactions. So this part is pretty similar to the other chains. So there are on the right part of the screen, there are a little more detailed diagram of like how exactly the private key is generated. Yeah, so you can, we won't go deep into that. You can take a look in Aleo documentation if you are interested in exact details. The second key, a view key, I think this is kind of a new concept for people coming from other blockchains. And well, this has to deal with the fact that Aleo is private, so then is encrypted. Transactions and like records are encrypted, and to be able to view these transactions, there is a view key. So each account has its own view key, and I can only use my view key to view the transactions, the records that belong to my account. I cannot view other accounts' data. Well, so and this key is derived from view key, from the private key. It's again base 58, 53 characters, and it also has a specific prefix. And yeah, it allows you to decrypt data on chain. Its main function. As per Aleo documentation, well, it is not supposed to be shared with anyone but like authorized entities. Well, it's not very clear now what can be considered an authorized entity. So, well, for now, I'd say it's better to avoid sharing your view key with anyone. Okay, and the third thing is address. Well, this address is pretty similar concept to other chains. It's derived from view key in case of Aleo, and it also has its own prefix. And well, it's required to interact with an account. I can take some microcredits, which is an Aleo native currency, and send them to another address. That's it. Okay, yeah, and now going to the next concept, which is a record. So each record has owner. So there are no records that don't belong to any account or belong to a program or anything like that. Now, every Aleo record belongs to a certain account. And well, if it is private, and by default records are private, then only the owner of this account, the one who has a private key, can view the content of these records. Well, apart from the owner, a record might store some microcredits and some arbitrary data. I mean, like program-defined data, and it has either private or public visibility. Yeah, and records can be created by transitions, and then they are consumed in a transition. So once record is consumed, it is no longer active anymore and cannot be consumed for the second time. That's how like double spending problem is avoided in Aleo. Yeah, and essentially the state of a user account is a whole set of unspent records belonging to this account, which is similar to UTXO model in Bitcoin, for example. Yeah, so what is Aleo virtual machine? So all the like execution environment of Aleo is called Aleo virtual machine, AVM in short. And essentially, well, this is a stack-based machine that executes some functions, uh, which is like, well, the description that fits for almost any virtual machine. But the second thing is what is specific to Aleo is it constructs a complete arithmetic circuit from each instruction in the function, which allows it to, well, this has to do with the zero knowledge proofs. Our second lecture will be fully devoted to zero knowledge, like introduction to zero knowledge for people who is interested. But for now, well, you can just know that arithmetic circuit is generated for each instruction, and well, this is what makes Aleo specific and AVM specific, as it allows to generate a proof for any code that is being executed on the virtual machine. And well, proofs are generated using the Marlin algorithm. And again, we'll go deeper into ZK specific topics during the next lecture. Well, as any blockchain, there is a global state, and in case of Aleo, it is represented by the Merkle root of the block headers Merkle tree. So there is a global state, and there are blocks, and like each block has hash and has a header that is contained in its header, and in each block there is a number of transactions, and in each transaction there is a number of transitions. So it's kind of like a Russian doll, so there is a block, inside the block there is a transaction, and inside a transaction there is a transition. So what is a block? So block structure is pretty similar to other chains. Well, it has reference to the previous block, which kind of creates the chain. So one block goes after the other, and essentially, like block header summarizes the state of the current block and of the whole ledger at the current time. What is transaction? Transaction represents a change in the of the ledger state, and there are several types of transaction. Currently, there are like two main types, which is an execute transaction, so where we essentially call a certain function of a certain program, and the other type is deploy transaction, where we have some code and we want to create an Aleo program using this code, and the programs are deployed on chain and are stored on chain and can be called also on chain. There are two main types, and the third type is a fee transaction. So we have to pay for execute and for deploy transactions, and there is a fee associated with each of types, and the exact amount of fee is dynamic, so it is defined by various parameters of like how large is your program. For example, in case of deploy, like how large is your program, how long its name is, like the shorter the program, the more expensive it is, and so there is a fee associated with deployment, and the same for execution. I mean, the larger part of the code you are executing, kind of the more you are supposed to pay for this execution. And well, as for fees, fee transaction, well, if transaction fails, so like neither execution nor deployment took place, you are just charged with a fee, because, well, anyway, like nodes of the network spend some resources executing your transaction, and well, someone has to pay for it. yeah, and transaction consists of transitions. So transition is kind of individual state change in some programs. So it can create and consume records, and well, it's described as a function in a program. We'll take a look at how it looks on one of the later slides. Yeah, but well, essentially, transition is described. Well, it has its own ID. It corresponds to a certain program, certain function in a certain program. It has its own inputs, outputs, and also its finalization block, which is executed on chain. And the first part of transition is executed off chain, and the proof is generated. Like ZK proof is generated, and yeah, so then validated by the nodes. Yeah, so this is transition, and the program, well, it represents some certain like piece of application logic, and also it has its own state. So first it has an ID, which is like unique in the whole chain. So if you deployed your program once and you want to, like, there is no such thing as redeploying in Aleo, and you'll have to rename your program to deploy the second version of it. And yeah, so there are some inputs that are provided into the program, and well, there is a state of the program which is currently represented by mappings, and also there can be some outputs output after the program is executed. And well, the code of the program is described in Aleo instructions and or Leo language. So let me explain like what's the difference between Aleo instruction and Leo, why we need both. So Aleo instructions is actually like pretty low level programming language, and well, currently like typical DApp programmers are not expected to use it. So it's like an intermediate step between like machine code and human readable code. And well, some certain types of use cases might require programmers to use Leo instructions, but generally we expect only Leo language to be used. So Leo language is compiled into Leo instructions, and then like Leo instruction code can be deployed on chain. Yeah, so Leo programming language is more high level. It's more human readable, so it has yeah, like has more appealing syntax. And well, it's pretty typical for the app programmers. Well, there is a typo on this slide, like copy paste error. Of course, Leo programming language is expected to be used by typical DApp programmers. This is the language we'll be focusing on in this series. So let's discuss what a typical Leo program layout looks like. So there are 6 like major parts. So imports, program scope, transition functions, helper functions, like these are different, structs, and records. So these are 6 types, and like let's look deeper into that. So here on the screen we can see a piece of Leo code. And well, imports is well, pretty similar to what you can see in other programming languages. It allows you to reuse another Leo file that is also part of your program. Thus, you can decompose your program, divide it into sub programs, and well, this can allow you to make your program more manageable, more maintainable. Well, program scope is basically where the program is described. In this case, hello.aleo is the name of the program. The name of the program is also the ID of the program. And well, inside this part of the program, we see that mapping is described. So here, well, the syntax again is, I think, pretty similar, pretty like self-explanatory for people who have experience in programming in other like languages, say Solidity, JavaScript, C++, and stuff like that. So here, like balances and mapping from addresses into unsigned integers that describe the amounts. Also, we can see records and structs, and well, let's yeah. So record is another important thing. So we discussed records this lecture before, and here we can see how exactly they are defined in Aleo program. So here we can see there is a required owner field, also like microcredits and amount, which is a user-defined field. And yeah, so these are records, and well, also there are structs. Structs are like pretty similar to records, but they are not. They only exist on chain as opposed to records that can be created and consumed off chain. Structs are only available on chain. And yeah, so in this struct, like the sender and some object are the fields of this struct. Well, now we are moving closer to functions. So here we can see a transition. So the transition function is the function that causes the transition. And as we can see on this screen, transition consists of two parts. So it's a transition keyword, and the other side is a finalize keyword. Well, we touched this topic a little on the lecture number 1, and that due to this like dual nature of Aleo, there is an off-chain execution part and an on-chain execution part. So transition keyword describes the part that is off-chain, and here we can see that record is generated. And the second part is finalization block. So this block is executed on-chain, and well, it can interact with the program state, which is also stored on-chain. And well, we can see that some mappings are modified, and yeah, so records are created in transitions, and mappings can be accessed in a finalize part. And also we can use helper functions that cannot access program state. They just encapsulate some part. You can extract some part of the programming logic into them to reuse your code. Yeah, and actually that's it for this lecture. I think that well, yeah, we decided to split our lectures in short parts so that they are more digestible. And well, we are also always appreciate all kind of feedback. Please feel free to contact us using any using Twitter, Medium, or Discord. I'm always available in Aleo Discord. Yeah, that's it. Thanks for your time, everyone.